It is widely accepted that Mars was once covered in lakes or oceans of water that disappeared to create the dusty red planet scientists are studying today. But the mystery of what happened to these vast waterways has deepened this week after the Curiosity rover discovered high levels of silica in samples of Martian rocks. NASA scientists are now turning their attention to discover why the composition of Martian rocks is so high in this mineral, and the research could reveal how acidic the water once was. Curiosity has found higher concentrations of silica at sites covered during its last few months of exploration than anywhere else it has visited during its 3.5 years on the planet. These high silica compositions are a puzzle, said Albert Yen, a Curiosity science team member at NASA's Jet Propulsion Laboratory in California. According to Yen, the concentration of silica in the rocks can be raised by one of two ways, either by leaching away other elements, leaving the silica behind, or by bringing in the mineral from somewhere else. Either of those processes involve water. If we can determine which happened, we'll learn more about other conditions in those ancient wet environments, he explained. The findings build upon NASA's discovery of dark fingers scarred on the rocky slopes of the Martian landscape, which indicate seasonal water activity on, or beneath, the surface. The key to the rock's silica content could determine whether the water in the region was acidic or alkaline. If the water was more acidic, with the reduced pH most likely due to sulfuric acid, then according to the NASA team, it would dissolve the other elements and carry them away, but leave the silicates behind in the rock. But if the water was more neutral, or even alkaline, it would carry dissolved silica that would deposit in the rocks. While both scenarios are being considered by the space agency, the acid involvement agrees with findings from another of its rovers, Spirit, on the other side of the planet. Spirit found signs of sulfuric acid fog scarred on the landscape. Curiosity has been taken samples as it travels up an extinct volcanic region of the planet called Mount Sharp. While the initial observations were reported to have been made in May, the team backtracked to take a closer look at some of the rocks. Samples drilled from one rock in particular, named Buckskin, unearthed a mineral called tridymite, a rare mineral on Earth, never seen before on Mars. On Earth, the rare mineral usually originates from igneous rocks such as lava from volcanoes which cools and solidifies. But magma can evolve on Earth to contain high levels of silica. The presence of tridymite at Buckskin could indicate magmatic evolution on Mars, said the team. We could solve this by determining whether tridymite in the sediment comes from a volcanic source or has another origin, explained Liz Ramp, of Aerodyne Industries at NASA's Johnson Space Center in Houston. She added, "A lot of us in our labs are trying to see if there's a way to make tridymite without such a high temperature." Since touching down on the planet in August 2012, the Curiosity rover has helped planetary scientists understand more about the planet's watery past. The rambling rover has covered an area of but the ultrafine dust of the alien world has taken its toll on the little guy. The last few months has been an uphill battle, with the rover ascending the side of the extinct volcano Mount Sharp. The latest findings were presented by NASA scientists at an annual meeting of the American Geophysical Union. What we're seeing on Mount Sharp is dramatically different from what we saw in the first 2 years of the mission, said Curiosity project scientist Ashvin Vasaveda of JPL. There's so much variability within relatively short distances. The silica is one indicator of how the chemistry changed. It's such a multifaceted and curious discovery, we're going to take a while figuring it out.